Good morning, everyone. It's supposed to connect. So I have a few announcements for those who are not attended yesterday class. Okay, for my section yesterday afternoon, I think you know. So we have announcement for the midterm test. So we're going to have a midterm test 2 weeks after this week. This week, week 7. Next week is week 8. Your independent study. I mean, like you're going to have a short break. And when you come back, return to campus, there you are. You're going to sit for your midterm test. And for today, we need to finish earlier, 15 minutes earlier, because of there are other classes who are going to have this venue for their midterm test. I'm still connecting. All right, and your midterm test, for those just coming, all right, we're going to have an MCQ overall. Instead that we understand, in previous I mentioned to you, we're going to have MCQ type of a question, including we're going to have short AC or short question types of. But we do a final moderation, and we found that it's quite difficult if we want to set short question. For example, if a student giving the answer which is not exactly as same as in the marking scheme, you're going to simply lose the marks. So we remove that structured questions, and we replaced it all together to the MCQ types. But still not available. Let's check. And I'm going to post the revision question for you to review later on. So while you have a holiday or you're going to have a break, if you want to do revision, it's available later. Then you just double check in this tab. Let's loot first. In the online exercise in here later. So far we have, for the online exercise, we have a quiz 1, quiz 2, and after that we have a quiz 3 and quiz 4. So the answer for the quiz 3 and quiz 4, once I finish today's class, this is a Friday, so I'm going to finish my class by today, then I can upload the answers there. Okay? And for your information, if you possibly can score quiz 1, quiz 2, quiz 3, especially quiz 4, I believe that you can score my paper. I really hope that we have a numbers of a student possible to get distinction. And how many marks for your midterm test? There will be definitely 13. So we have a 30 question, 1 question, it will be 1 mark. So the percentage is quite high for you. And I found there are 3 or 4 number of students, okay, sending the email and also leave application. I really don't understand why you send me that leave application. The reason, you say that you're going to have a Salesforce training. So let's look the email from your lecturer and my faculty. I think really clear stated in here, all right? If you look at this, I make it bigger and zoom for you. There you are. This is your Salesforce training, the schedule, and look at to that. It's affected on 22nd November. 22nd November is our midterm test. But morning, now, like now, the time is 8 to 9, 1 hour. And your training basically is on at 2 p.m. And I understand a day before, you're going to have a training up to the 9 o'clock at night. So early in the morning, you need to come over here and sit for your midterm test. So it's not affected what to do. as a students, you also have a quite heavy load as well as us, the lecturer. So we need to work on this together. And for this 22nd, for those who are coming, I mean your class is this morning, all right? On Friday, 8 o'clock, you need to sit for your midterm test on 22nd. There's no excuse. If you're absent, therefore, what happened? You will be marked as a 0. One thing is good about this midterm test is you're practicing your quiz exercises. Anyhow, when you done your midterm test, automatically you know what is your grade. So that is the marks for you. So automatically you will get your marks. So yeah, work the best, okay, for this module, because I understand some other modules is quite difficult to be scored. So you have your group assignment, and your group assignment, basically, I found many students or some of groups, you know, they are done their group assignments. So for today, we're going to talk about this one. We're moving forward to the new topic, new chapter, which is this, logic gates. So for me, I'm not quite worried much, because of we are passed through all the difficulty of the topics for the CEO. So we're done with a numbering system. That is one of quite difficult for those who are not familiar. And then we also done for the operation, and we know that changing some of numbering base from the base 1, base 2, base 8, octal, hexadecimal, and decimal to binary. So in your midterm test, you are not allowed to bring your translator device. For those who are from China, you are not allowed to bring your translator device. You need to bring your dictionary, as well as same as in final exam. Number 2, any of electronic calculator or manual calculator also is not allowed. For me, it's not required for CAO midterm test, even final, because of we used to give you a small number to convert, and the conversion is not required any of a calculator. All right? So we're also done with the numbering system operation. So numbering system operation, I believe that it will be subtractions, that's the first, additions, and multiplication. So what will be in the midterm test? All this operation. So this operation will be involved with the binary number, and you need to know how to convert decimal to the binary. Then my major concerns is basically for the subtraction. So whenever the number will be given in your midterm test, as long as it's not negative, you need to change to negative value, especially minuend, subtract hence minus. So only that are major concerns. Next will be machine instruction. So this topic is a topic chapter 4. Okay, so only this topic will not bring into your midterm test. We do not have machine instruction, which is related to description table for our midterm test. All right, we're going to bring this topic to final exam. Okay, bro, faster, sit, bro. All right. And then we stumble to the assembly language. So I hope that my co-lecturers, my team, helping the other sections to explain how we're going to use logical shift to the left, logical shift to the right, arithmetic shifter to the right. We don't have rotate, and also that one for data processing, and also another instruction, comparisons. They will have a question about CMP, CMAND, working together with branching instruction. So branching instruction, we understand, is just the only to help us to write down whatever that condition in selection statements or repetition statements. I also have the recording, okay, through the My Time at the announcement tab. You will see there is a recording. All right, so we done this, and then this will be in your midterm test. Now, all this harder topic for the computer architecture, simply we just move it out. And started today up to the week 12, we're going to have simple and theory weeks, which is the topics is quite like you just need to understand, you know, probably just that skill cognitively. So this is a topic logic gates, about logic circuits. And then for today, okay, it's only basically the first part. We also have part 2. And because of I found many of our students from the foundation, they are done with the logic gates, logic circuits, so easy for them to come up with the truth table, and then for them to produce the SOP, some of product, and some of them, they are really clear. They know how to draw the, key maps. And then again, to draw the logic gates. So in the logic circuit, it's the same as well as what a student from Faculty of Engineering done, you know. They also learn the same thing, how basically to create the logic gate. I mean, if you want to have like a integrated circuit, you're going to use a lot of a transistor, you're going to use a lot of a resistor, and kind of these devices is being used to represent logic gate. So this is a topic. For me, only half an hour I can finish this topic because most of you possibly familiar with this topic. So in the logic circuit, we have three kind of logic circuits. First, the gates we call basic gates. Number 2, universal gates. And last, exclusive gate. Okay, let me start. So when we talk about the logic gates, in and out, open and close, true or false. So we understand same as well as in numbering system, right? We have 0, it means off. And then if we have a 1, it's representing there is a signal or voltage or the energy. The streams, a wave, they will have a wave. So that is in these Boolean theorems. So leave it Boolean theorems to you. If you want to know about that, you can basically Google or just ask your ChatGPT about what is a Boolean theorems. So Boolean came with a truth table, which is to ensure either that your logic gate is correct or not, okay? And then how you're going to arrange, you need to have a truth table. The name was a truth table to show which one is true, which one is false, which one has a signal, which one do not have a signal. As simple as that. And then how we going to draw the truth table. So for example, that you have A and B input, only 2 inputs, so 2 powered by 2. You're going to have 4 entries. If let's say you have 2 input, they're going to have 3 inputs, so 2 powered by 3. And in your group assignment, okay, this topic covered. Our MLO covered logic gates in your group assignment. So another way to say, which is this topic will not cover in your midterm test, even in your final exam. Only in your group assignment. There's no more question regarding on this topic. Okay? All right. So in your group assignment, we have how many of inputs? A, B, C, and D. We have 4 inputs. Definitely, you're going to make sure your entries in your truth table have 16 bits. So you're going to produce 16 of SOP later. So we have 16 entries. That's why we'll see your group assignment. You have A, B, C, D, and then you need to have an output for the car and truck and void. Impossible to be done. So we have 3 of output and then 4 of input. These are very simple and easy things. If you look at this example, we have the example of a truth table for 2 entry, 3 entry, and 4 entry. The arrangement. So they have a student came to me yesterday during my lecture and they said, Miss, we can see that arrangement for the first input and second input and third input. Okay, I have a friends. They change this kind of arrangement. If you look at the arrangement for the 2 input, we have double of O, and then double of 1. That's arrangement. And then you look at the entry, okay? And we also have here the next, which is B. Okay, we have a 0, 1 and 0, 1. So this is basically the arrangement has been set up by Boolean when we want to draw the truth table. So my student said, my friend did actually the first signal 0101 and the second signal will be 0011 and the output is the same. Yes, that is for the two signal. So what happens if, let's say, you have a 3 input, you have a 4 input? It's totally wrong. So the arrangement is exactly like this. So if you look at the arrangement for the 3 input, A, B, and C, so this arrangement, how many of bit we have in the 0 in the A signal? We have 4. So it's generated 8 because 2 powered by 3. We have a 3 signal. And then the first of the input is a 4, 0. And the next arrangement is a 4, 1. And the rest will be following the sequence. And then if we have a 4 inputs, we have 16. So 8 bit for 0 in the first column, and then 8 bits for 1. So if you change this one, whenever that you have many signals, increment of a signal, and then you change the arrangement, definitely your output and your logic gate would have a mistake or error. Okay, only for 2 signal, it's available if you change. Because there's no difference, A and B, because only 2 inputs. And I introduce to you to the gate, basic gate we have OR, and NOT. So OR, this is the OR, okay? And we have also AND. Another one we call inverter or NOT gate. Only 3 basic logic gates, basic. Okay, so we go to the OR, and then you look at to the slide. OR, the signal when we have a 1 plus 1, it means first input is on, and the second input is on, definitely the output will be on, okay? And then after that, we're going to use that symbol plus. We also have another symbol. We can take a look later when you come back, return to campus, about another symbol in your exercise. So in OR, when you want to apply or you want to use this OR gate, what happened that as long as it has a signal in any inputs, the output will be on, which is 1. So look at to the truth table. So this is a truth table for OR, and next after that they will have the logic gate for the OR. It seems like a moon, and which is a little bit curvy. So this is the OR gate. And then you see, as long it has a signal in the input A and B, they will have a output. That is OR. Okay. So how many of input can use this logical gate? We can have more than 1. We can have a 1 here. Okay. We can also have 2 here in this input connecting to the gate. And then we can have 3 even in this input. We can have a 3, A, B, C. We can also have a 4, more than 1. We can create the line at the gate, near to that gate symbol, to represent how many of an input you have. This is for OR. Next, we have AND. Another example of a OR. In this case, it's a 3. Just now, for the 2 input, this is for the 3. You can see that near to that logic gate, the symbol, we have a 3 line, A, B, and C. So you can have kind of this. Look at this. This is for AND. So for AND, as long as it has 0, so there's no signal. It means there's no output, or there's no value in the output. Look at the truth table. Yeah. You see, as long it has 0. Just now, in OR gate, as long as it has a signal, it will have an output. In this case, as long as it has 0, no output. That's why it's written to, if you look at to here, 0 all, except the last row. The last row will have 1, 1, and then here, 1. And this is how the symbol, straight. Just now for the OR gate, a little bit curvy. This one straight. So this is representing AND. And the denotation, we have here like a dot at the top. X equivalents A dot B dot C. We also have another symbol. We practice that later. in our exercise. Truth table showing that using AND gate with a 3 signal. As long as it has a 0, and you can see that there's no output. So this is an AND, and this is how does this look like for your AND gate when you have a 3 inputs or 3 signal. We also can see which is there is a higher voltage or a lower voltage. You can take a look on this one. And then I present to you the last basic logic gate. We call it as NOT gate. NOT gate or inverter. We call it as a NOT gate or inverter. Invert or negate the value. So same goes like when we use this term in our numbering system. We want to negate to 1 complement, negate. We're going to put into the opposite of a value, this variable. So for the NOT or inverter, okay, they use this kind of over bar we call a prime symbol. So I found in many of my student group assignment came to me asking for checking. They always like to use this prime symbol. It's acceptable, all right? And we look at to the over bar, this is the over bar, and the symbol has like a dash at the top of it. Okay, it has a dash. So how are we going to read this one? A naught. Okay, or we can say inverse A. So only this gate is only have 1 and allow 1 signal input. Okay, either 0 or 1. And the inverse, opposite. Look at to the table. All right, on your right, we have a 0, inverse to 1, and we have 1, inverse to 0. That's all. How does this look like? Is this. This is the gates. And even it's obvious if you used to have any simulator to draw the logic gate, as well as in your group assignment, you're using voice circuits. Okay? So we can see that there are many kind of a logic gate that you can apply drag and drop, and then you do a connections for the wired. So for the NOT gate, you'll find like this. Especially in the front, there has like a small circle. So to say this is NOT. Okay? So we'll say that here in the box, the circuits always have one only, the only one single input. The others you can have more than 1. This is a wave, and it's okay. This is a summary for today's class. If you apply OR gate, what will be the output? If you apply AND gate, what will be the output? And NOT gate, just for the basic. And once we done that, I guess this is a very simple for you. We have combination of a gate. So when we say combination of the gate, we're playing around with a NAND gate and NOR gate. NAND gate is basic combinations of an AND gate with the inverter, with the NOT gate. And if we have a NOR gate, I mean we're going to actually combine OR gate with the NOT gate. And it's become universal gate. We're not called basic gate anymore. Another type of the logic circuit, we use universal gate. So it's combinations of NAND and NOR, combinations of this and all together with a NOT. And OR and NOT and AND gate can combine in your circuit. So I have a student come, okay, for your group assignment. You need to draw at the end of the group assignment, the requirement, you need to draw the logic gate using the circuit, right? Circuit verse. So you can have, just to share with you, you can have 3 logic gates, 3 drawing, okay, for the car separately, and after that for the truck, and then you have for the void. So some of group, they combine, draw and cut together, but seem like we can see the connections, you know, the wire, it will be a little bit messy, but still accepted. And you will find, okay, in your group assignment, if your simplifications of key map or the group of a key map little bit different with the other group, it's fine. For us, as long as the rules in that question, the group assignment question, there's the rules, right? At the beginning of the questions, there's a rule. So as long that the rule is a fitful, you've been accepted. So maybe what you have done, you compare with the other group is different. But if we test in your logic circuit, it is correct. It's logic, so we accept. No worry about that, okay? Might be have a similar things, the output, or maybe not. So, okay, this one, I'll leave it to you. You can see the combinations of the AND gate and NOT gate. And then we have here, also combination. Is this expression, basically, we have a two input, A and B. And then these two input will have a connecting to the, what we call AND gate. So we have A dot B for the A and B. And this A and B connect to the C. So the next after, they will have a C input. So A not B. And we have a gate there, which is a plus, which is a OR gate. So we can take a look on this one. This is the last output. Every single of a gate always having a one signal output. One signal output. If you look at to that one, only one signal output. We don't have more than one. All the logic gate always one signal output. And then this is what I want to highlight. You learn in your maths, the formula in maths, in the maths, mathematical formula, we learned that we're going to operate. We'll be given this arithmetic, will be operate multiplication operation and division in the first place. But in logic gate, if you have parentheses in your algebra expression, you need to solve that first, like this second example. If you look at to the second example, you see parentheses first, right? So A plus B will be in the parentheses. You need to solve this first, okay, at the top, and after that you're going to multiply or using AND dot C here. So parentheses basically is the most prior in our logic gate drawing or illustration. I further up. So if you look at to this example next, which is about inverter or NOT gate, inverse. So it's a quite, I think, easy, this topic. So how do you feel? Previous we have a topic quite challenging, converting the numbering and then operation. Then we have instructions, machine language, and after that we have what they call it, assembly language. What do you feel? Release, right? So this topic and onwards, okay, is easy topic. So you can feel your final exam question later. We have a multi-core later about the microprocessor. So kind of all readings. So for those student she or he doesn't like reading theory, I think it's a bit challenging for you. For those they like, okay, they are right brained. Okay, the way how they think is a right brain is more, I think, stronger than left brain. Is good for you to score your final exam. Because all reading about subjective questions, abstract. So let's we go and see in this inverter. So for the inverter, we can apply, we can combine also with any of gates. Look at this one, okay. First, I can see that we have A input, and then after that, this A connecting to the gate of NOT inverse, okay, inverter. That's why they have A bar there, A NOT. And then I see I have another input B. And then this B is not connected to that NOT, but it's connected to the OR NOT here. And I understand this one, the output, when they combine, they become that one, A NOT. Here is a OR, which is plus there, with B here. That is the A example. Look at the B example. We have A and then have a plus, which is the gate of OR, A or B. So that's why the output here, A plus B. And then there's a inverter, NOT. These two, A and B example, a little bit different. If you look at B and A here, there's a difference. The bar, over bar symbol, there, combinations A plus B, okay, at the end. But in A example, we look at that, A bar only, not B. So we understand that this is the way how it's right if we're using the NOT gate or inverter gate. Yep. And the NOT gates, in this case, in the first place, A will be before you combine. And then the NOT gate in B example, after then you combine. So you can apply this NOT gate in anyhow, in any of condition. But careful, even I am your lecturer, always to have this, exercises, do the error. Human error, ma. Human error. So I want you to ensure that your logic gate is correct. Some students, the truth table in their group assignment is all correct when I check. And then the problem, they are having difficulty to form the group in key map, okay? So when you are problem in grouping in the key map, will be affected your logic gate because you draw your logic gate, you're not following the rule at the end, at the beginning. You're following one is in your key map. So we have the rules question. Next, we have the truth table. After that, you have key map. And then you need to simplify the key map using the group on the key map. Then you draw the logic gate. So we have a group of students. They draw logic gate based on the key map. We also have a student, they draw the logic gate based on the truth table output, the SOP of the truth table. And we also have a student do comparison, quite good. They used to have a theorem, the law, which is we're going to cover later in the week 10. The law of a logic gates. We have idempotent, we have annulment, and so on, many law. So they use this because they are, smart. They know how to use the law, and they simplify using the law, algebra, simplifications of expression, algebra expression, and then they use K-map. Then they compare. So when they compare, that's not correct. Both of these methods having a different output or results. So they come to me and they ask, Miss, which one is correct? I say, which one that you draw the logic gate, it's able to show the output exactly as the question asks you. I say, oh, I'm using a K-map, that's correct. But it couldn't work if I use the simplification. So there's something wrong in the simplification. And then I say to you, okay, honestly, all right, there's no right and wrong for your group assignment result or answer. As long as the logic, we test your logic is correct and following your truth table or following your K-map or even following your simplification using the law, we accept it, okay? If I, the clients, and all of you is engineer, come from different company, so you give it to me the proposal, all right? I'm your client, so I go choose which one I want. So you are my engineer, so you come with a proposal, you come with the B proposal and so on. Of course, I compare which one is more effective, which one is the best, which one is within the budget, okay? So if let's say the one that group, my engineer from the, the another engineer from the company A showing to me using simplification and it's workable, effective, it's fine. And then we have engineer from the company B and send to me, it's workable, but look at to the traffic light. In any area, I'm going to specify in Malaysia. You go to Cyberjaya. Anybody have been in Cyberjaya? MashaAllah, good. Okay, at the night time? You live there, okay. Where is it? Which part? Masrika or Tamarind Square? Huh? Oh, okay. So at the night, you look at the Cyberjaya, the light always off. The road is dark. Why? Because they're using a solar system. LoRaNet, one of my friend company used to. Okay, it's able to apply, but one thing you see, not convenience, okay? If you jogging in Cyberjaya, you feel like, wow, so nice, this spacious, but you feel afraid a little bit. Yeah, many dogs, stray dogs, one thing, many pig cross the junctions, and then it's going to be darker, okay? The government can choose, okay, to take that company to apply that, okay? But the thing C, the efficiency. You see the traffic light in Cyberjaya, Putrajaya, Kuala Lumpur, okay? In that triangle, Times Square. My God, it's the worst. Okay, some of traffic light in Cyberjaya, even though it's like say in the middle of the night, you are there, you stop, you high beam in the traffic light, the traffic light will turn to the green color. So it has indicated the sensor to sign there is a car, you can go. The other junctions, like say for example, you are in the T junction, the other junctions there's no car, so you can move automatically. This is what happened in Riyadh and also in Dubai. You just beam, high beam, they can detect. So it's more efficient. Same goes to you. You can send to me all the answer, but which one is the best? Which one which is acceptable based on efficiency, effectiveness, reliability, performance? You get the marks. But we don't know who's going to get the marks, full marks, who's going to get extra marks. Okay, those are indicate to me, come to me, Dr. Sari, blah, 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 blah. Especially my students from my sections. And I said, yeah, what you want for your group assignments? They work hard for that. So they come up with a tree of a logic gates. I said, do you have extra marks for this? Of course, if you have a work hard, you do something extra from other people, extra mile, you were awarded. Okay, so that's the thing. So we can take a look on the other gate, okay, the combinations NAND gate and or NOR gate. I want to show you here. If you used to have that logic gate, we call universal gate, combination of that. Oh, anyhow, we have done with this. Oh, yeah, this is NAND gate. I think you know, right, how to combine the NAND gate and the other gates. Look up to here. This is NAND gate. Same, the symbol will be, both of them is acceptable, just the symbol. The first one, they have, this is for NOR gate, they will have a small circle denotation there. And then this one, they combine non, okay? Everything is the same, like an OR gate, the output, but when you negate, they're going to be opposite, invert. It's the same goes to the NAND gate. Okay, this is NAND gate. We accept if using the first of symbol, and then this is the second, negate. See the output, wherever is 0 become 1, and 1 becomes 0. So khalas, we done for today's topic. So happy holiday to you. I end up this lecture because of we need to give you away 15 minutes to the other class to do setting for their midterm test after us, now 8:45, all right? So attendance. After that, you may dismiss.